In this video, I'll be working through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths paper 3-2. I'm going to try and show you how to do this question and not just the solution. So you may need to pause and rewatch certain parts of the video. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. In question 8, we have a differential equation we're asked to solve. Now, the first thing we tend to do in this question, it's often dy dx. In this case, it's dx d theta. That doesn't really make much of a difference for us. We often have this, we will have this differential in the question if it's a differential equation. Dx dt. What we want to do is we want to separate them out and get them each on their own side. What I mean is on the top row as well. So we leave dx where it is and we're going to want to put d theta at this side. So multiply both sides by d theta. This disappears, reappears over here. And we want to, with this dx, we want all the x's with it. In all of this, the only x is from this term here. So we want to move this over the left side. That means dividing both sides. So 1 over 4x plus 3. And then we want all the thetas on the right side. Cosine theta is already here. We don't do anything to that. This term though, we divide both sides by this and we'll get sine over 2 theta. Okay, I think you'll probably get a mark for doing this. Next up, we need to integrate both sides. That's how we solve differential equations. So I won't bother putting it now. Basically, we can just add and integrate to both sides and do it. It shouldn't have too much problem with the left side. We'll go through it in a few minutes. It's the right side that's the difficulty. I don't blame any student for looking at this and going, well, sine and cosine, they go together. They become tangent. They become 1 over tangent, unfortunately. And that's, we can integrate tangent, but it's much harder to integrate 1 divided by tangent. And more than that, it's 1 divided by tangent of 2 theta. Too difficult, so that's not the path you should go down. There's a substitution here. Sorry, let me put in this integration. So let's split this into 2 questions. I'm just going to do this one first. The integral of cosine 2 theta over sine 2 theta d theta. And oh yeah, we don't have any limits for this. Okay, how do you do this? There is a substitution that works nicely here. What you want to look out for substitutions, usually it's the bottom row we're going to substitute. So it's something that when we differentiate it, it will divide into the rest of the question and destroy it or make it simpler in some way. The good news is here, the derivative of cosine is sine and the derivative of sine is cosine. For giving a plus or minus here, which I think the cosine would be turns into the minus sign. So they both seem very promising. It couldn't be the top row. If we change cosine, we'd get a sine, but then we'd end up dividing everything by it. So we just have 2 signs on the bottom row. So the answer here is the substitution we're going to find is the bottom row. U is equal to sine 2 theta. We're going to use that. And what I tend to do at this point is just try. If you think it through a little in your head, you plan ahead a little bit of a path, but then just try it. If you go wrong, don't worry. In the exam, your exam paper should be full of, imagine this is your exam paper, an attempt here, an attempt. It should be full of things like this. Just a couple of lines through it. You don't want to make it unreadable to the examiner, but a couple of lines through it. You should have loads of mistakes in your exams. Okay, this is not going to be one. This works out. U is equal to sine 2 theta. So the derivative of u is equal to, the derivative of sine is plus cosine. We'll assume this is something simple, this 2 theta, we'll assume it's just theta. And we'll fix that assumption with the chain rule. So we end up going to have to multiply by the derivative of this, this thing we simplified here. So we multiply this all by 2. We'll put it in out front there. And that means if we rearrange this, that's a theta, not a t. If we rearrange this, we would get d theta is equal to 1 over 2 cosine 2 theta times du. So if I try to replace this original thing we had here, this we'll call it I1 because I'm going to have a few more i's there. This I1 here, this integral 1, it's equal to the integral of cosine 2 theta. But this bottom row, I've replaced that now with u. This d theta, I found out by doing this, that's what this bit does. It finds out that I can replace d theta with this. So I'll do that, 2 over cosine 2 theta du. This cancels with that, and we're left with a 1 over 2, that can come all the way up front, and the integral of 1 over u, d theta. And we can do that quite easily. It's a half natural log u. But remember, we know what u is, so let's squeeze it in down here. We know that's a half natural log. What do we replace? Oh, this guy here. Sine 2 theta. It's okay as well if you can do this in your head. A lot of students are just quite good at this and go, well, I'm going to substitute this. It'll cancel in this 2 here, the derivative here, will end up dividing everything. I'll remember that. I'll be left with 1 divided by u, and that's natural log. I'll be left with 1 divided by sine, so it's natural log that with the 1 over. It's okay to do it in your head. This is the slow, methodical way to do it. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Now let's do the other integral we left off. Make a bit of room here. The integral of 1 over 4x plus 3 dx. Again, lots of students can do this in their head. That's fine. I'll do it slow again. I'll also use a substitution. U is equal to 4x plus 3. In this case, we're not trying to cancel anything. We're just going to substitute it out because it's too difficult to do on its own. Again, though, a lot of students can just look at it and go, well, it's going to be the natural log. Sort of like a chain rule, simplifying it in your head, knowing we're going to differentiate this and then divide by it. Anyway, let's do it slowly. U is equal to this, du dx is equal to 4. That means rearranging it, dx is equal to 1 over 4 du. Writing this out again, we get the integral of 1 over u, 1 over 4 du. That's the 4 can come out front. And that's just natural log again, 1 over 4 natural log u, which is equal to 1 over 4 natural log of 4x plus 3. Now I've left out a mistake in both of these, which I'm going to fix when I put them all back together. Really, this guy, where's the final answer down here? This guy should have a plus a c. So should this one here, plus c. And yeah, let me keep all the constants going. As we'll call this c1, c2, and I'll clear off the board here, and I'm going to combine these two answers. I'm going to have this is equal to this. So I'll rub everything out except for this, and we'll put these two answers in below it and continue on from there. Okay, here it is all combined again. These constants, let me just talk about them for a moment. And they're very important to remember. They're not important to number like I've done. For example, let's take C2 away from both sides. C2. A constant taking away another constant. Well, that's just another constant, a whole new constant. I'll call it C3 here, but it's okay just keep calling them all C. You'd have to be a little careful though, you'd have to be careful because they're not all the same number, and that's why I'll just put in different numbers each time. But it's okay for you to get away with it once you don't mess it up right at the end. Now we're nearly finished. We're going to get a lot of the marks for this. We've done the hard work, the integration. You still want to obtain an expression for x in terms of theta. We want to rearrange this so we have x on its own, x equals, and the only thing unknown on the other side is we want to be theta. So let's start doing that. And let's multiply both sides by 4. Yeah, let's be cheeky and just do it like that. 4 divided by 2 just becomes 2. Oh, if I'm multiplying both sides by 4, this becomes 4 times C3. I better be. Again, you're not going to lose any marks for just leaving a C there, because it's just a whole new C. Okay, get rid of the natural log. We take the exponential of both sides. So this side just get 4x plus 3 e to the power of natural log of something, it just becomes that something. And this side, let's see, it comes in 2 natural log sine 2 theta plus, well, let's call this C4, a whole new constant. Right, what do we do here? This e and this natural log, can they cancel? Not quite at the moment, it's a little too far away from each other, but we can, well, let me save a bit right here. Remember the rules for natural log. 2 multiplied, or anything multiplied by a natural log, that can just reappear up here. Instead of the 2 there, it's the same as the 2 there. And now just this C4 is a problem. If we rewrite this as e natural log sine squared 2 theta, again this 2 can be wrote in here as well, that's just trigonometry, we get away with that. E to the power of C4, well that's just the same as being multiplied by e to the power of C4. Or again, this is now constant. E to the power of C4 is just a whole new constant. Could call it C5, which is fine. Could call it just C. But the thing, we actually tend to call it A when it's multiplying an exponential like this. So this is just still just a constant, we don't know. And this E and this natural log destroy each other. So let's write that. 4x plus 3 is equal to A times sine squared 2 theta. We're pretty much done. Rearrange this. We get, yeah, let's do it all in one go. We get x is equal, let's see, we have A sine squared 2 theta minus 3 all divided by 4. So that's A over 4 and 3 over 4. Again, let's replace, let's call that A1. And we'll replace this with now A2. Again, you don't have to do it like this. You can just have this constant continue from the start, or you can just keep calling it C if you want. And this is pretty much done, except the only problem with this, you're going to lose 1 mark for this. They don't want the constant. They want to know what number that is. What number should be where I have A2? Yours might look a little different at this point. And we get that because they gave us enough information. They told us at some point x is equal 0. And at the same point, theta is equal pi over 12. So A doesn't change, that constant, that's what it means, it doesn't change. So we can just put these numbers into this. Instead of x we put 0. A2 says there, sine squared, instead of 2 theta, we have 2 times pi over 12, that becomes pi over 6. And then take away 3 over 4. Pi over 6, that's, well, that's how I remember anyway, that's 30 degrees, sine of 30 is a half. So put this in your calculator. Sine pi over 6, you'll find it's 0.5 or a half. A square of that is 1 over 4. So 0 is equal to A2 times 1 over 4 minus 3 over 4. We can already see A2 must be 3. But let's do it slowly. 3 over 4 is equal A2 over 4. Multiply both sides by 4. We get that. 4's cancel. A2 is equal 3. I think you would still lose a mark, or maybe half a mark if they do them. At this point, even though you've done all the work, they just want you to write this again. This line up here one last time. X is equal, instead of A2 though, they want to see the 3. They want to see the number 3. Sine squared 2 theta minus 3 over 4. That's your final answer. If you got a constant at a different point, that's perfectly okay. Once you got to the same last answer, we all should be getting to the same last answer, or something's gone wrong. Yeah, that's it for this question. If you have any follow-up questions about this, anything I did there, ask me whatever you want. I'll do my best to get back to you. Give me some help though by telling me where in the question you're talking about. Okay, thanks for watching and have a great day.